Hello, everyone. Thanks for joining us today. We're going to be talking about centralized operations management on AWS. It's where you can automate operations anywhere. My name is Brian Henderson. I'm a senior solutions architect here at AWS. Joining me today is Pal Patel. She's a partner solutions architect. Customers use AWS to host their workloads and look to us for a modern way to manage operations of those workloads in the cloud. In this webinar, we will be providing information on how to manage operations in the cloud, the benefits of doing so, and finally show a demo of the AWS services that accomplish this. The agenda for today is to go over what AWS Cloud Ops is. Then we're going to be talking about starting with customers. Here at AWS, we like to work backwards from the customers. And so for centralized operations management, we work backwards from the customers and we start with the customers. We'll talk about that a little bit. Then we'll describe what is centralized operations management. Further, we'll talk about how does AWS enable ops for customers. And then we'll describe some ops services that scale with you to help you accomplish your goals. So on this slide, I'm going to give you a high level of cloud ops and how cloud operations management fits into your operations. Similar to DevOps, IT ops, SecOps, and SysOps, AWS Cloud Ops describes the roles, processes, and tooling for cloud operations success to achieve outcomes such as controls, agility, availability, speed and safety, and ease of use. AWS Cloud Ops helps customers enable, build, or operate their workloads in the cloud, on premises, or at the edge. First, AWS Cloud Ops model makes it easy to set up a foundation for operations. You can scale quickly with enterprise governance when you have security and multi-account built in. You can easily set it up in minutes, deploy guardrails, and enable governance. Second, AWS Cloud Ops model helps customers decide how much of their existing infrastructure and applications they want to sustain and keep, how much to build new, and how much to migrate on their journey to the cloud. Third, the model lets you operate from one central hub. In observability, data drives decisions. Untimely downtime in applications and services costs money. Therefore, it is critical to resolve issues as close to real time as possible with observability. You can collect data, monitor performance, analyze patterns, and act on that data. Compliance is top of mind for many organizations, and you're subject to internal, industry, local, and global regulations that are complex and dynamic. AWS Cloud Ops streamlines compliance and security for you by automating many of the manual compliance tasks so you can shift your focus to scaling and innovating. With centralized operations, you can act on what you see. Everything comes together in our central ops hub that can quickly respond to anomalies, out of compliance issues, and security alerts with pre-planned and automated actions. Cloud financial management is a key part in all stages of the model, and the model is underpinned by automation and security. Customers can use the AWS Cloud Ops model to automate the management of application performance, availability, and governance at scale, so you can operate easily, successfully, and securely in the cloud. Customers are asking AWS to help them unlock the speed and agility that is made possible with cloud scale and elasticity. They want to understand how to synchronize engineering and operations to ensure consistent and efficient delivery of their applications. Enterprises tell us that while they need to get to the cloud quickly, it is crucial for them to maintain their operational alignment with ITIL processes that drove their operational success in the on-premises world, such as incident management, change management, problem management, and so forth. They have spent decades acquiring experience in each of these operational domains and have built their operational models around these tools and processes. They have shared that many operations management tools tend to be monolithic. They operate in silos and do not provide native cloud integrations requiring them to build custom solutions. They are designed for manual processes that are time consuming. This, in turn, hinders the rapid pace of cloud development and negatively impacts their cloud adoption initiatives. Startups, on the other hand, tell us they want operations to be embedded into their development processes with a high degree of automation so that operational best practices are built in as they try to get to market quickly. As they scale their platforms and customers, they want the ability to operate seamlessly at the same pace. These customer insights define the need for a solution that bridges a gap between their existing and desired operations models and enables them to be ready for the future. So, how do we enable centralized operations management at AWS? Starting from the bottom, AWS lets you automate operational processes across your environments with agent based management that works on AWS, on prem, edge and IoT, and even other cloud providers. Customers can start with cloud operations management as they migrate by using these same services for on prem resources. Customers with complex hybrid and multi cloud environments can standardize on one set of processes and services. We integrate data for resource configuration, observability, and compliance and other events data from sources such as AWS Config, CloudWatch, CloudTrail, and EventBridge for a consolidated lens to the state of your resources. Moving up to automation runbooks, we let you automate frequent, high risk, or compliance related activities. This is key to scaling while maintaining security, improving resiliency, and reducing risk. AWS has over 400 predefined automation documents or runbooks that you can use and customize for your environment. Or you can build your own using Python or PowerShell. Runbooks reduce time to resolution and reduce manual effort. Customers can improve security posture by reducing individual access to underlying infrastructure and having a delegated admin for pre-approved runbooks. Moving up to the light blue section, these automations can be triggered by any of your operations processes. Change management lets you define change templates and either automatically or manually approve them as your org processes require and trigger automated execution at a predefined time. Event management lets you identify issues, launch automations to resolve, triggering a change management operation, or execute break glass actions like launching a session. Incident management helps you define incident response plans for mission critical applications, notify responders, provide relevant underlying resource data for troubleshooting, collaboration through AWS Chatbot, and resolve incidents through automation or break glass processes. Finally, it provides root cause analysis data and recommended next steps, including problem management for recurring incidents. Systems Manager also gives you node management capabilities such as inventory, patch management, remote session management, and more, which can integrate with your automations. Moving up another level to ITSM solution. If you're using an ITSM solution such as ServiceNow or Jira Service Management, the AWS Service Management Connector gives you bidirectional integration, eliminating manual processes and data entry. These processes and automations can be performed at a resource level or in the context of an application or workload as defined by AWS Service Catalog, App Registry, resource groups, or tagging. And finally, to the top in the dark green section, compliance data such as state of resources, alerts and alarms, compliance rule status, actions performed by who and when is collected throughout these processes, which can be surfaced in AWS Config and Systems Manager or holistically through AWS Audit Manager. Systems Manager is a powerful service with a breadth of features and capabilities. We've categorized these features into IT service management, application management, and node management. Many of these features can work independently of each other, letting you adopt Systems Manager for the use cases that make sense for your business first. At the bottom of this slide is Quick Setup. Quick Setup helps you set up Systems Manager's features easily for many use cases such as scanning instances for missing patches, configuring collection of inventory, creating and configuring IAM profile roles needed, and many more. Automation is the next underlying service, and we'll go into automation in the next slide. Now to the different components of what Systems Manager manages. Systems Manager's IT service management feature work in concert with AWS services, leveraging automation to help bring visibility to and automate resolution of any issues. They can work independently, or if you have an ITSM solution such as ServiceNow or Jira Service Desk, integrate through the AWS Service Management Connector. And below are some of the features of Systems Manager that fall under IT service management. Next section is application management. Systems Manager's application management feature help you manage and operate your application resources in a context relevant to your application's teams and resource structures. And here are some of Systems Manager features that fall under application management. Now we'll move to node management. Systems Manager's node management features give operators the tools they need to perform day-to-day activities to maintain your environment. Below are some of the Systems Manager features that fall under node management. Next, we're going to go over the services that we're going to be showing you in the demo that Paul is going to demo with. Automation is a key feature of Systems Manager, helping you scale consistently and easily. It works across Systems Manager's capabilities, letting you eliminate manual errors in your environment by authoring repeatable runbooks, triggered by event bridge rules, maintenance windows, state manager associations, change manager, and more. Automation enables you to do some of the following. Customers can build automation workflows to configure and manage instances in AWS resources. Customers can create custom workflows or use predefined workflows maintained by AWS. You can receive notifications about automation tasks and workflows by using Amazon CloudWatch events. Customers monitor automation progress and execution details by using the AWS Systems Manager console. Some of the use cases with automation are customers can perform common IT tasks. Automation can simplify common IT tasks such as changing the state of one or more instances, using an approval workflow, and managing instance states according to a schedule. Customers can safely perform disruptive tasks in bulk. Systems Manager includes features that help you target large groups of instances by using Amazon EC2 tags, and velocity controls that help you roll out changes according to the limits you define. You can simplify complex tasks. Automation offers one-click automations for simplifying complex tasks such as creating golden Amazon machine images, otherwise known as AMIs, and recovering unreachable EC2 instances. Customers can enhance operation security. By using a delegated administrator, you can restrict or elevate user permissions for various types of tasks. And finally, customers can share best practices using automation. Automation lets you share best practices with the rest of your organization. Next, we're going to talk about OpsCenter. OpsCenter is our event management engine. It lets operators view and investigate operational items, sometimes known as ops items, automatically generated by CloudWatch, config, and CloudTrail data, and then resolve them with automation documents. It also integrates with ITSM and ticketing systems such as Jira and ServiceNow. AWS Systems Manager OpsCenter enables a standard and unified experience for viewing, working on, and remediating issues related to AWS resources. A standard and unified experience improves the time it takes to remedy issues, investigate related issues, and train new operations engineers and IT professionals. A standard and unified experience also reduces the number of manual errors entered into the system of managing and remediating issues. More specifically, OpsCenter offers the following benefits for operations engineers and organizations. You no longer need to navigate across multiple console pages to view, investigate, and resolve ops items related to AWS resources. Ops items are aggregated across services in a central location. You can view service-specific and contextually relevant data for ops items that are automatically generated by Amazon CloudWatch events and CloudWatch application insights for .NET and SQL Server. You can specify the Amazon resource name, otherwise known as ARN, of a resource related to an ops item. By specifying related resources, OpsCenter uses built-in logic to help you avoid creating duplicate ops items. You can view details and resolution information about similar ops items. And finally, you can quickly view information about and execute Systems Manager automation documents to resolve issues. Finally, we're going to talk about Incident Manager. Incident Manager lets you resolve critical applications issues faster with automated response plans to declare and track the incidents, notify responders, resolve with automation documents, and provide post-incident analysis to help prevent recurrence. Incident Manager reduces downtime for critical applications by letting you create response plans to manage and respond to incidents. Incident Manager helps you prepare with response plans that can be triggered by CloudWatch alarms. Response plans automatically notify the correct resources and launch automation runbooks to quickly address the issue. All relevant data about the incident and underlying resources is surfaced in one console for full visibility without hunting through different tools. Teams can collaborate via chat and resolve problems with Systems Manager's native capabilities like Run Command and Session Manager. Post-incident analysis information is gathered and presented clearly to help teams learn and improve applications to prevent future recurrence. Here are some of the customers and partners that are using AWS Centralized Operations Management in their workloads today. Now, I'm going to turn it over to Paul Patel to show you a demo of those three services that I described before.
Thank you for the overview, Brian. Now we are going to see some of these services in live action. I want to demonstrate a scenario from IT operations utilizing various tools we have within AWS. One in particular I want to show today is how we can make use of Systems Manager agent running on the EC2 instance that gathers software inventory from the instance and then utilize AWS config to evaluate that inventory data to specific configuration state and basically automate the operation if the instance is in non-compliant state. For the purpose of this demo, I'll have a config rule monitoring the compliance for unapproved application list and take specific action when a non-compliant resource is found. I already have an Amazon Linux 2 EC2 instance running that has AWS Systems Manager agent installed and set up to collect the software inventory. On my screen here, you can see the example of the inventory being pulled by Systems Manager that shows various applications installed. Now, let's head over to AWS config. Here I have a managed role that verifies none of the applications specified within the rule are installed on the instance within your environment. Optionally, you can also specify the version of the application. As you can see here, the rule has already identified one EC2 instance and marked it in a non-compliant state. Next, what I have done is I've utilized event bridge rule that will trigger based on compliance state change for the specific config rule that we just saw. Basically, this event rule will trigger whenever the config rule becomes non-compliant for any resource. And since we saw that the config rule already has one EC2 instance in non-compliant state, this rule has already triggered. Now within this rule, I have set up a target to create Systems Manager ops item. So what it does is when the rule triggers, it's going to create an ops item. And within that ops item, it is going to define the information that it gathered from config. The input transformer within this event rule helps me define what particular details I want to gather from the config and then pass it over to ops item or the target that I create with this event rule. Now let's head over to the Systems Manager OpsCenter console. We can see that I already have one ops item open here. It says in here, I've got an ops item that was generated because it saw there was an instance in non-compliant state. Basically, it caught an instance running an unapproved application. Here you can see a lot of data related to this resource that you have with the specific issue. If we go to the related resource details, we can also see the data gathered from AWS config for this resource. In this particular case, the details are related to the application. It's the inventory that config was evaluating. We can also narrow it down to the particular application that we are monitoring as part of our config rule. Now from OpsCenter, I can use automation to take desired actions. I can run automation runbook from here. So I can pick my resource. I can run the automation. I can choose the runbooks that are available from AWS, or I can also create my own custom automation runbooks to take specific action. Now, the action in this situation could be to either stop the instance or terminate it. However, perhaps the IT person that is reviewing this ops item is not authorized to take that action. Now, this is where we can utilize change management. So we already have created an automation runbook that utilizes SSM Change Manager. The document will go ahead and initiate a change manager request to stop the instance. So let's go ahead and run this automation runbook and take a look. Let me get the instance ID for this automation. And here is the custom automation runbook that I have created to initiate the change request. I'm going to use an automation role that I have already created and hit execute. Now, let's take a look at some of the primary components of the change manager while that request is coming in. So there are two primary components to change manager. One is change template. That is a collection of configuration settings in Change Manager that define things as required approvals, the available runbooks, notification options for change requests, etc. And second component is change request itself, which basically is the request to run an automation runbook or the action that updates one or more resources in your AWS or on-premise environments. So in this case, our change request is to stop the instance. I already have a stop EC2 instance change template created, and using this change template, we submitted the change request. As we can see, change request has already been submitted from our action that we took in OpsCenter, and it's awaiting an approval. I will go ahead and approve this change request. I can optionally specify comments that identify this change. Now that I have approved this request, it will put in the queue the automation document or the runbook to stop the instance. We can go to the automation console from here and take a look at that. So this was our automation runbook that was initiated from ops item to make the change request. And now we see that after the change request was approved by me, it has initiated AWS Stop EC2 instance runbook to stop the instance. We can also see the instance that is being stopped here. Now, as we are waiting for that instance to stop, I want to quickly summarize the scenario we just saw. Here, we had an Linux instance running SSM agent set up to collect software inventory. We then utilize the config rule to evaluate the inventory for compliance monitoring of unapproved applications. And when it does find an instance with such an app installed, it will put the resource in non-compliance state, which triggers our event rule. And our event rule will then create an SSM ops item, which sort of provides you with a central location to inspect, analyze, and resolve the issue. And from OpsCenter, we submitted a change request to stop the instance that ultimately resolved our issue. Similar to how we created ops item for that specific issue, consider now that we have an incident of unplanned service interruption or reduction in the quality of service where we need to gather people to collaborate, analyze, and resolve issues. And now that's where we will use Systems Manager, Incident Manager, which was one of the service that Brian spoke about. Now, I have a sample here that is looking for high CPU utilization of a critical instance of my demo app application. Automatically, when this alarm goes into the alarm state, it's going to create an incident within an incident manager using the response plan I specified. Here is the alarm that I have already created. And the action for this alarm is to create the incident whenever the CPU utilization of my critical instance reaches above threshold. Now let's log into the EC2 instance using remote session capability called Session Manager, which is again a part of Systems Manager. Now we will simulate the high CPU spike. This will make my alarm go off and ultimately create an incident. I'm going to run a simple stress command. And supply a threshold that above 60, which is what I provided in my alarm. While this CPU spike takes time to reach the threshold, let's talk a bit about Incident Manager. So within Incident Manager, there are again several components, but two primary components that I want to talk about today is response plans. So it lets you define steps on how to respond to the incident. It includes information about who to engage, the expected severity of the event, any automatic runbooks that you want to initialize, or any critical metrics to monitor. Second part of Incident Manager is escalation plan. It works in stages and basically lets you define the context that you want to involve and when to involve them. We can now see that the CPU utilization on my instance has breached its threshold and the alarm has changed to the alarm state. This should have triggered my alarm and created an incident. So let's head over to Incident Manager and see. So I can see that we now have an incident created. Let's take a look at it. From within the incidents, I can verify the metrics to see what is going on with the CPU. I can gather various other information as far as what's been happening during this specific incident. You can also have a runbook that you can initiate, such as we have a sample one here for escalation that will take you through different tiers within your incident, such as you triage the issue, perform a diagnosis, take steps to mitigate the issue, and finally summarize the recovery. You can also take or initiate another runbook if you want to. So in this case, I'm going to go ahead and start a specific runbook that will remediate the issue. And basically, I will restart the EC2 instance. So let me go ahead and find the runbook. Actually, let me grab the resource from my incident. I'm going to start the runbook. I'm going to pass the EC2 instance here. Leave the role to default and start. One of the extra action that I have taken here as part of this incident response plan is I have integrated it with my Slack channel. So whenever the incident goes off or any important activities related to this incident is also emitted through to Slack via SNS notification. So we can also take a look at my Slack channel here. So here is the response or the message that I have in my Slack channel here that indicates the incident started right now. And it also shows me that I have added or initiated a runbook to mitigate the issue, in which case here is AWS Restart EC2 instance. This incident will also create a ops item in your ops center to further analyze or track the issue. Finally, you can go over the details of the incident with information that it has gathered from other places as well. Once I have remediated my issue or incident or the cause of the issue, I can go ahead and resolve my incident. Another nice thing that Incident Manager allows you to do is perform post-incident analysis. It allows you to select a template. This is the default one that is provided by AWS, which guides you through identifying improvements to your incident response, any key takeaways that you want to get from this incident, uh, including reducing the time to detect or mitigate the issue. An analysis can basically help you understand the root cause of incident better. With this, I want to conclude my demo and quickly summarize the second part of the demo that we saw with Incident Manager. In this case, we had again a test EC2 instance running Linux, and we had a CloudWatch alarm monitoring the CPU utilization of this critical resource. And as soon as the alarm detects the CPU reaching the threshold or going above the threshold, it triggers an incident which helps me to involve or engage appropriate contacts from within my organization or from within my IT operations team, and for them to collaborate, analyze, and resolve the incident in a proper manner. That is all for the demo that I had today. Again, thank you all for joining us.
Thanks, pal. There
Okay.
are 3 takeaways that we want you to know from this webinar. 1, instead of data siloed in disparate places for your application workloads, AWS provides a centralized place for operational data. It aggregates data in a single console to gain actionable insights. 2, with Systems Manager, customers can automatically resolve application issues, shorten the time to detect and resolve operational issues, and implement best practices proactively. And 3, AWS can help with solutions. Systems Manager helps you establish operational control over your cloud resources. Systems Manager enables you to protect existing organizational investments with service requests, incident management, problem management, and change management capabilities. So how do you get started and test out these features in Systems Manager to help your organization? You can dive deep and read about the centralized operations in the cloud through our AWS documentation. Two, or you can go to the blog and see some use cases that other customers have used for the Systems Manager features to help solve their operational issues in the cloud. And three, talk to your AWS account team. They can set up workshops or activation days that you can get hands-on experience of utilizing these Systems Manager features that can help you and your organization. To help get you started, here's some QR codes to use to get to some of these artifacts that I mentioned before. We want to thank you for your time and joining us today. Everybody is busy. Everybody has a load of problems to solve in their organization. We hope you found this information useful. Please reach out if you need anything else. Thank you again.